All right, everybody, I'm ready to make this real. We're going to get into some real world stuff right now. Well, about as real as we can get in my home lab. I say it's real, so let's go with that. So when we talk about NSX managers, as we did in our previous video, I drove home the concept that the manager is also responsible for the control plane. And when I said control plane, this is what I was really talking about. The manager maintains these tables. It maintains an ARP table, a MAC address table, and a TEP table. And I'm going to explain what each one of these are. So starting at the top, we have the ARP table, also known as Address Resolution Protocol. If you don't come from a network background, I can explain it in about 3 seconds. ARP just means we are mapping an IP address to a MAC address. And in this case, we're showing a VNI. This is just telling us what network segment that this IP and MAC address is assigned to. And we don't have to assign that manually. That just happens from an NSX standpoint. We also see on the right here that we have this column labeled transport node, and we see host 5. Now we're going to get into transport nodes, so I don't want to dive down this kind of rat hole right now, but in a nutshell, just think of transport node as a vSphere host. So we basically, by this ARP table, what happens is when this server pings, and actually let me show you. So I listed an IP here. This isn't actually the right IP, but I think you'll get the point. So let me switch to my lab. All right, so we're here in my lab. I have vCenter set up, and I have this VM web01A. And we see here I've got this IP 10.200.0.100, and I've got a MAC address. Let's actually get into that VM and look at it. So if I do IPA, I can see my MAC address ends in 1CE4. So just to make sure I have some kind of traffic being generated on this, I'm going to go ahead and ping, because I want to make sure my tables are populated so I can show you this. Okay, so it's not a big deal that it didn't ping. I just wanted to generate something. All right, so I've got that traffic generated. Now let's also take note real quick. This VM is sitting on this host 254.11, and that'll be key. We'll come back to that. But for right now, let's take a look at the actual tables. So if we go back here, let's say this is the MAC address that we just looked at for that VM, which it is different, but let's pretend it is. And we would have the IP listed here now. We would also see a VNI for whatever segment it's connected to. And then finally we would see some kind of identifier for that host. We would also then see a MAC address that would show us the association between that MAC and what host it's on, specifically what TEP it's on. Now this is kind of interesting because in traditional networking, a MAC table, the whole purpose of it is to take a MAC address for some kind of endpoint that it's seen and then tell us what interface to send it to. It would say something like Ethernet 1/7. In the case of NSX, that interface is actually a TEP. Remember, TEP is really just an interface that sits on a vSphere host. And then finally we have this TEP table where the whole purpose of this is to map the actual TEP IP to the TEP MAC address or the host MAC address. So if you're kind of going from the top down, the way it would go is that web01 VM would go to send traffic, this table would get populated. Then it would have another entry here for some other endpoint, right? Something it's trying to talk to. And the controller would basically say, okay, well, I see that there's a MAC entry for whatever you're trying to reach. Maybe it's web02A. And I see that it's on host 5 TEP. And then I'm going to go into my TEP table and say, how do I encapsulate this packet and put it on the wire for the host 5 TEP? I need a MAC address for that. And it's going to get that from the TEP table. So let's take a look at the actual controller and see what it looks like. All right, so I saved you the login process, but suffice to say, I just did an SSH into my NSX manager, and you can see I'm in the NSX CLI command mode. If I type ? I get a bunch of options, and these are not typical Linux options, so you can tell I'm in some kind of special CLI mode, which, as I said, is NSX CLI. In here, this video is not meant to show you kind of the inner workings of that CLI, but I'll tell you a little secret. Really, the get command will get you just about anywhere you need to go. That was a horrible joke, but it is the truth. So if you type get ? you see I have all kinds of options. Get logical switches, get managers, NTP servers. If I want to know routes, by the way, this is routing from the management standpoint. So if I do get route, that's just routing out of my manager. If I want to get specifics about my overlay networking, I can do logical routers, logical switches, etc. In our case, let's focus in on that web01A VM. So I'm going to do get logical dash switches. This is going to give me all of the logical switches I've created, which you can just think of logical switches as just a broadcast domain in NSX. In this case, that VM is connected to web-seg. I know that because I saw it in vCenter. I also see that there's this unique identifier. This is added to that segment, and you will want to know this or be ready to copy and paste it because a lot of commands in NSX CLI will require it. So in our case, let's go ahead and do get logical dash switch, and I'm going to paste that in. If I do a question mark, you'll see why. It's asking me for a UUID or a VNI. I'm going to paste this in. Then I'm going to do another question mark. We see very quickly we have a bunch of options. I'm going to kind of highlight the ones that are really key, and these are the ones I had on the slide that I just showed you a minute ago. The ARP-table, the MAC table, and then also the VTEP table, or the TEP table. So let's kind of start at the top there. We'll go ARP-table and hit enter. We see here that I have the IP of the Web01A VM, and I have the MAC address associated to it, and I have this transport node ID. This is just what host it's sitting on. And we see that we've generated this VNI of 73728. Well, if you go up my screen a little, you see that VNI is associated to the web-segment. So any VMs connected to that segment will show up with this VNI, and that's how we're going to encapsulate traffic and make sure they get to where they need to go. So when the other end receives this packet that's encapsulated, it's going to look at that VNI, and it will have the same table or a very similar table, and it will strip it off and say, okay, I know what VMs need to access, or what VMs are connected to that segment rather, and I'll make sure I forward the traffic appropriately. Continuing down that path, let's go now take a look at the MAC table. And keep in mind, we're just looking at the MAC table for this one segment, for web-seg. We see here I have a couple of or a couple of MAC addresses rather, and I know one of these is for my Web01A VM, and I know another is actually for a different VM that's also connected to this. And I can see that the TEP IPs are different between the two. So keep in mind this IP, so 19.5 and 19.6, and I want to show you guys this. This is really interesting. Alright, so I'm back to vCenter, and I wanted you guys to remember those IPs, 19.5 and 19.6. So let's find out what those TEPs are. Now, in my environment, these are the only two hosts or transport nodes that I have in NSXT. So let me click on one of those, and we're just going to guess. I'm going to go to Configure and VM kernel adapters. That's all a TEP is. It's just a VMK interface, which is just another IP that lives on this node. In this case, we see we have 19.5 and 19.4, and interestingly enough, you see the TCP IP stack says VXLAN. This is created by NSXT, but as I mentioned before in our overlay video, NSXT is actually using Geneve, so it's not VXLAN, but we can ignore that. Regardless, the point is these two interfaces are dedicated for those TEP endpoints. So these are the TEPs that would show up in those TEP tables. And then we still have a management IP for this vSphere host. Those are two separate things. Let's take a look, because I said 19.5 and 19.6. So let's look at our other transport node. And we can see here, this one has 19.6 and 19.3. I believe I'm using DHCP, so that's why they just kind of got whatever was available. So kind of going back to that, we see very quickly that we have these TEP IPs. So what this is really telling me is, I know about this MAC address, and I know that that one is on this vSphere host, and I know this MAC address is on 19.5, which is a different vSphere host. I could also tell they're different by looking at the transport node ID. If they were the same host but just different IPs, then they would have the same ending from a transport node ID standpoint. It'd be the same thing. So hopefully this was helpful. I just wanted to give you guys a quick rundown of kind of what the control plane looks like and get you kind of enough information that you can run with it and start exploring in your labs. We're going to get to the actual deployment of the NSXT manager here very soon, so I'm looking forward to it. I'll see you guys there.